If we were continuing on with the reading, figure 3 shows you that it's a double loop system. So kind of going through that circuit that I just kind of talked to you about moving down, going towards the bottom of the body here, and then coming back up. So if I'm tracing, let me get that other blue. Okay, if I'm tracing that other blue, I'm going to bring in my blood from the bottom parts of the body, also top parts of the body, and I'm going to put it into the right atrium. I'm going to push it to the right ventricle. And then I'm going to push it out, okay? And I'm going to take it to the lungs. I'm going to use purple for this because it gets into, smaller veins called venules. Venules attached to capillaries. Capillaries attached to arterioles. Arterioles go back to big arteries. So I'm going to U-turn that blood. I'm going to pick up oxygenated blood. And I'm going to bring it back to the heart here, into the left side of the heart, the left atrium, left ventricle, and I'm going to push it up into the aorta. It will go up to the top of the body as well as the bottom of the body. I'm going to come back down here where I'm going to mix with those, I don't even know what purple I had earlier. I'm going to mix with those capillaries. I'm going to U-turn it, and then I'm going to make that trip again back to the heart. So yeah. So those words that I was using, artery, vein, capillary, let me see if I can pull out a red pen. Your heart is connected to the rest of your body through a system of vessels, which are illustrated in figure 3, which we just looked at. Not all of the vessels in the body are the same. Different vessels have different structures and functions. An artery carries blood away from the heart. So artery starts with A, and A rhymes with away. Okay, so that's how I remember what my artery is. It moves away from the heart. These are thick, muscular vessels that bring blood away from the heart. This is what you feel a pulse in, okay? So this is where you take your pulses. A vein, I don't have any fancy tricks to remember this one, but a vein takes blood toward the heart. If you can think of something with that, please let me know. And then these veins, they're, I want to say floppier, flimsier. So if an artery looks like this, okay, has some, there we go. A vein would be represented kind of like this. They don't have a very rigid structure, doesn't really have a lot of blood pressure in it. It just kind of blood glugs along in it back to the heart there. And then I have my capillaries. I draw them in purple because I like to consider capillaries a mix of blood. This is where you exchange kind of the deoxygenated blood and oxygenated blood, or you turn it back to the heart. So that's why I draw it in purple, because it has a mix of kind of both of that blood there. Capillaries are used in diffusion. This is how I exchange my carbon dioxide and oxygen gas in my lungs. And it's also how I get nutrients through the intestinal wall into the body where the cells kind of need it. And then blood pressure, the force with which a ventricle of the heart contracts, is what creates blood pressure. This is the pumping action that you feel when you are aware of your heartbeat or your pulse. The pumping action of the ventricles is strong enough to push blood throughout your body. Okay, pumping action of the ventricles is strong enough to push the blood throughout your body. Without blood pressure, blood would not be able to reach all the parts of your body. Again, it's what you feel every time your heart beats. You feel the force of the blood pushing against kind of the walls of your artery, and that's how you get your pulse. All right, so finishing up this section, it kind of asks you to make a little bar graph, I guess. So I'm going to use, I guess it's like a gray for resting and a white for intense exercise. So starting with the brain, let's see. Your heart pumps more blood through your body when you exercise. The rate of blood flow, however, does not increase in all parts of your body. The table shows how the rate of blood flow changes for different parts of the body during intense exercise. So starting with the brain, at rest, it's about 750, and intense exercise is the same, 750. So I'm going to go up to where I think 750 would be on this graph, and they're the same number, so I'm just going to draw my bars, and remember that one was resting and one was after exercise. Heart muscle 250, and then intense exercise is 750. So I'm going to go to where I think 250 is. This middle line seems to be about 500, so I'm going to go half that. And then again, I think it said it was 750. Yep. Okay, so I'm going to go up to where I think 750 is and draw a bar. Your kidneys, got a big number here, 1100. So I'm going to go up. If this line is 1,000, I'm going to go just a little bit higher than that and make a bar. Okay, and the next one is 600, so a little bit higher than the halfway mark. Skeletal muscle is 1,200, so a little bit higher than where I just drew that last bar for the kidneys. Got a little crooked there, but I guess you kind of get my meaning. And then all the way up to 12,500, so this is a big one. So this is going to be all the way to this line. See if I can make my line relatively straight. Okay, and then for the skin, 500. And 1,800, so almost all the way up to the 2,000 mark. All right. And there we have our bar graph. Hopefully you came up with something a little similar. So if you have any questions about this kind of first section, please let me know. Thanks, guys.